Okay, so in the previous example, we saw the idea of what if you were the first chemist and you had to build a redox table, and you did it by checking a whole bunch of metals and their corresponding ions and seeing what reacts with what. Now, the last one I did took a long time, and what I want to show you now is how we can smash these rather quickly if we're economical with our work. The idea is that if you have your redox table, strong oxidizers are up in the top left. Those are things that will react with pretty much anything. So any metal ions that you find, you can take that the other way. If not only is it true that if you're a strong oxidizer, you'll react with lots of stuff, you can also say, if I've got an oxidizer and it reacts with a lot of stuff, it must be high on the list. And if it doesn't react with as much stuff, if you have something like the lithium ion, which is super weak, it's way down here, and it hardly reacts with anything, that tells you that it's lower on the list. So here's the blazing fast way to build a redox table. Looking at these ions, ion W reacted with only one thing. So that I'll give it a reactiveness rating of 1. Ion X reacted with 1, 2, 3 things, so I'll give that a reactivity of 3. Ion Y reacted with 2 things, and ion Z didn't react with anything. So on the basis of that, the highest reactivity would be X. That means the highest ion on my list should be X. The next one in line is the one that reacted with 2 things, ion Y, followed by ion W because it reacted with a single thing, and finally ion Z that couldn't make anything happen. So there's the ions in order from the strongest oxidizer to the strongest reducer. Now, in some questions, that's all they want, but more often they'll ask for what this question wants, which is create a redox table, which means we need all this information, but we have to actually write a table like the one in the book, which means for each of these we have to do a reaction where it does its thing. It collects an electron. This one is plus 2, so it would want 2 electrons to turn into Y metal. W would be okay with just 1 electron, and that turns it into W metal, and same with Z. And if you want, you can put strongest reducer and weakest reducer on this side. That part's not really necessary, but what's in this box is what you need if they want you to create a redox table. So if you're looking at metal ions, you're going down this side of the list. The other option you could have had is to look for metals. This is extra now, but so you may zone out at this point. But the most reactive metals are down in this end, the strong reducing agents. So if you find a metal that reacts the most, here, let me do this table so you can read all this. I'm going to say on this side are most reactive metal ions. So on our redox table, we have things like gold and silver and mercury up here that react with most other things. Down in the bottom left corner, we're down to least reactive metal ions. Things like lithium and calcium and sodium that have a really hard time getting any kind of reaction going. They generally don't do anything. So you can look at the ions like I did and build your table on the left side. The other option you have is you can look at the metals and you could say the most reactive metals will be found in the bottom right of the table. And as you work your way up the table, you get to the least reactive metals. You may not want to carry both of these versions around in your head, but if you do know them both, it is a good thing. If you'd done this with the metals, I'll just quickly show you how this would have worked. You'd say metal W had 2 reactions. Metal X, no reactions at all, 0. metal Y, 1 reaction, and metal Z, 3 reactions. And then the table you would have built would have been Z is the most reactive metal, so it goes in the bottom right. The runner-up is W. After that is Y. And the least reactive of our metals was X. And look at that. If you do it that way, X, Y, W, Z, you get the same table as you did paying attention to the ions. I normally work with the ions, and I think I recommend that to you also. It's what we usually expect you're going to do. But if you wanted to pay more attention to the metals, you could build a table that way also. Just remember, if you're looking at the metals, the most reactive one is in the bottom right corner, and then they stack up after that, which may feel a little less natural, but it does work.